In this tutorial, I'm going to show you how to create this AvidCNC keychain using your new laser. Now, we've worked really hard to make the process of creating laser toolpaths as easy as possible. And for the most part, they're just like creating router toolpaths with a few special little differences and a little bit of setup. So we're going to jump into that setup right now. One of the first things that we need to do is create a new tool in our tool database. That's the laser. So we're going to go into Toolpaths and Tool Database. And you may have a list of tools and groups here. Find a spot that you want to create your new tool. I'm going to put it in this group called Eric. And I'm going to hit plus to start the creation of a new tool. For the tool type, we're going to use end mill. If you have the option for laser cutter, don't use this. Use end mill instead. You'll see why in a moment. And for the diameter, if you're running the 15-watt laser from us, you're going to make that diameter at 0.007 inches. Don't worry about the number of flutes, and we're going to hit copy settings. I had done this previously. You may have some different settings here. We're going to change them all anyway. So whatever you have there, just go ahead and hit copy. So I've got my diameter correct. The pass depth, I typically like to make a number like 0.02. You can change this depending on what kind of materials you're cutting. If you're cutting something really light like foam, the pass depth can be probably a lot larger. If you're cutting something like plywood or plastics, you might want to have a smaller pass depth. Very similar in thinking of how you would set up a router tool. The step over, I recommend making at the same diameter as the beam spot, so you can make that essentially 100%. What we're doing in Mach is we are taking a router toolpath, and in Mach it's getting changed into a laser toolpath. So that means programs like Aspire, VCarve, Cut2D, Cut2D Desktop, Fusion 360, and other CAM programs can send regular routing toolpaths, and we will change them in Mach for you to a laser toolpath. And what we're doing is we're setting spindle speed to laser power. So if you set your spindle speed, quote unquote, for laser at 100 RPM, that's going to operate the laser at 100% power. If you set this at 50 RPM, this would operate the laser at 50% power. Now, these power levels and speed settings can vary depending on the material you're cutting and the strategy you are using to cut it. We'll publish some suggested feeds and speeds for different materials in the document below. But for this tutorial, we're going to go ahead and set this up at 80% power. And for the feed rate, I'm going to make this 125 inches per minute. And the plunge rate, I'm also going to make 125 inches per minute. Now, one of the most important things with setting up a laser tool is that you have the tool number set correctly. Now, by default, in Mach, we refer to the laser as tool number 99. Unless you've specifically changed this setting in Mach for a reason like, for instance, you have a custom ATC setup or something other custom, like a digital probe, you won't need to change this, and you will want to make sure this is set at tool number 99. If you haven't already, name your tool. I like to call mine 15-watt laser so I know which one it is. If these settings all look good, press apply and then OK. Now, let's talk about different toolpath strategies. For this keychain, as you can see here, you'll see that I have the Avid logo engraved, and I've actually cut out the outside, including the hole for your keychain. And to do this, I used two different types of toolpaths. Now, I'm running Aspire here, so I have a whole bunch of different toolpaths, and you can actually use, theoretically, any toolpath, because in Mach, we transfer them to laser toolpaths. And I'll show you what I mean. So let's say you want to set up the toolpath for cutting this out. So in routing, you would just select these two vectors. You do a profile toolpath. And I'm going to go in here and I'm going to select our newly created 15-watt laser. And for the cutout, I'm actually going to turn this up to 100%. And I'm going to drop the speed down to 80 and 80. And I'm going to hit apply and select. And I'm going to want to cut this on the outside, as you would do if you were routing. So that's really how you can think of making a toolpath like this. Just think of the laser as a router and set up the tools accordingly. So for the cut depth, I'm going to make the cut depth 0.1 inches. That's about the thickness of the plywood that we are cutting through. And one thing you want to be mindful of when you're doing this is that the cut depth can't be higher than the distance of the tip of the laser to the top of the material, because the laser nozzle is significantly larger than the path that it will cut. So you can cut thicker materials than the distance of the nozzle to the material surface, because the laser beam will shoot down through the material. So that doesn't always mean your cut depth needs to equal the thickness of the material you are cutting. So we'll go in here and we'll set this to outside, and we'll set the passes to, let's do 4 passes. And we'll go ahead and hit calculate. Now you can see this calculates just like a normal tool path, and if we zoom in really close, you can see that it's cutting on the inside of the key tag cutout, and up here on the outside of our key tag, it's cutting along the outside, and it's just barely doing it because the laser beam itself is so narrow. Now let's say I want to fill in this Avid logo and make it pop a little bit more. You might reach for the pocket toolpath, and in a lot of cases this is actually a good way to make something like this pop. So I'll go ahead and select it as you would do. I will click the pocket toolpath, and I'm going to select the 15 watt laser. I'm going to change the power level to 40%, looks pretty good, and the feed rate I'm going to make 120 and 120. I'll hit apply and then select. And when you're making pockets like this, you just want to make sure you're only using one tool. So I'm just going to remove these other tools here, and we'll go ahead and hit calculate, and let's see what happens. Now this works, and in fact it works really well. It is taking the diameter of the laser and filling it all around these letters. From experience, given this tool tag is only a couple inches by a couple inches, this would work. It might be a little smoky in plywood, and it might be sort of an unnecessary amount of material removal if you're just trying to make these letters pop. Now, something to note, when you are doing a pocket toolpath, you can change the step over, but the maximum amount that you can change it is 100%. You cannot make it 120% or really anything over 100%, which limits you to making a pocket with a step over that looks like what we see here. Now there's another type of toolpath that's available to you that actually works really well for making things like this pop, and it's called Quick Engrave. So with this same letter selected here, I'm going to go click this Quick Engrave toolpath, and I'm going to go select that laser again. So I'll select that laser, I'll keep these speeds and feeds the same, and what the Quick Engrave toolpath lets you do is fill in things with a step over that is larger than the diameter of the tool. So if I hit calculate, I can get a nice fill in like this, and you can play around with this number 2 to get exactly what you want. And oftentimes this can have a really nice effect with the laser, and will allow you to spend a lot less time and a lot less burning filling in an area. So this is one of the real advantages to being able to use non-laser toolpaths with the lasers, that you can do tricks like this. So I'll go ahead and add in the CNC logo down here. Just make sure we have all of these selected, and I'll go ahead and hit calculate. And now we're going to get a really nice effect where it's going to fill in around these letters and then trace around all of these vectors. The last thing you need to do is make sure you are using the AvidCNC standard post processor. Save out this toolpath and just save it in a location that you'll remember, and later on we'll be loading it up in Mock. So next we're going to get this job set up to laser on. And what you can see here with the setup is that I've got my regular spoil board underneath, a sort of raised sacrificial piece of plywood that I'm using to find my XY coordinates, And then the thing that I'm actually lasering is that smaller thin piece of plywood attached with the blue tape. And to set this job up, we're going to be using the touch plate to find the corner of that raised section of plywood, and then again using the touch plate to find the top of the material that we intend to laser on. We'll start out by taking our 0 plate and hanging it off the lower left-hand corner of this sacrificial piece that I have attached to my spoil board. You'll take the magnet that you would normally put on your spindle bit and actually attach it to the bolt on the mag plate. Jog the laser nozzle over the top of the touch plate, and then once you have that set up, we're going to go open the touch plate utility. So before we open the touch plate utility, you're going to want to make sure that the laser is deployed. And to do that, press the laser deploy on switch and your laser will deploy. Next, click on the Auto Z touch plate. This will bring up the familiar touch plate utility. But we've added a couple things that are specific to laser that I'd like to point out. We've added a new tab up at the top called Laser, and when you're using the laser with the 0 touch plate, you'll want to be on this tab. There's also a value in here for beam distance, and this is the distance of the nozzle over the top of the material. And this distance is important because you need the cone of the laser beam to be focused perfectly on the top of the material. By default, this number should be pre-populated with the correct distance for your laser. In this case, it's 4 millimeter. So unless you have a specific need to change this, you can typically leave this number alone. For this probe, I'm going to pick the lower left-hand corner because that's where I have my touch plate. Go ahead and select that, and we'll watch the probing process take place. The probing process works almost exactly like it does with a spindle. First, the laser is going to go down in the Z direction and do a touch off, and then it will go, in this case, to the top and then to the right. And if you're used to probing with our touch plate utility, normally you'd have to put in the diameter of the bit that you're probing with. In the case of the laser, you don't have to do that because we already know the diameter of the nozzle, and that's preset up for you. Next, I want to make sure that I'm perfectly zeroed over the top of the material. So I'm going to place this material on top of my sacrificial sublayer here, and I'm going to touch off to the top of it. And to do that, I'm going to flip the touch plate over and jog my laser over the top of it, and then jump back into the touch plate utility and do the center touch. That is just going to do a Z-axis probe. And as you can see here, the laser nozzle is moving down in Z. It'll touch the top of the plate and then pull back up. And now we've established where the top of the material is. So now that I'm all done Z-zeroing, I'll detach the magnet and store my Z plate safely away. Now let's double check that the zeroing worked properly. You don't have to do this every time, but if you'd like to check, you can go to MDI, type in Z0, and press cycle start. So now you can see the laser is moving down in Z, and if you watch the DRO, it'll eventually arrive at 0. And when we're at 0, the tip of the nozzle of the laser is actually going to be a little bit above the material, 4 millimeters to be exact, which is what we said earlier. And this is exactly what we want because it gets the most powerful point of the beam, the tip, right on the top of material where we want it. Now that we've got our material and zeroing all set up, let's go ahead and load the G-code that we created earlier. You load it in the same way as you normally would load G-code, but there's one special extra step with laser. There's a new button that we've added to the right called Process Vector Laser G-code. And if you press this button, your G-code is scanned and it is turned from routing G-code into laser G-code. So you're going to want to press that button and follow the prompts. And it will ask you if you want to create your file. It will go through and scan it, and here it says success. So your file has been prepped and is now ready for laser. You don't have to reload it. We've gone ahead and done that for you. You can check the preview in the preview window just like you would with a routing toolpath. And if everything looks good, you can go ahead and press cycle start. Make sure you put on your safety glasses and get to cutting. Before you press cycle start, make sure your laser is armed and ready to go, and you've got your safety glasses on. Before the job starts, there are 2 last prompts that you need to get through. This one here is prompting you to do a new Z offset. Since we did this ahead of time, we already touched off to the top of our material, we can go ahead and click past this one if you had started a job and not touched off to the top of your material, or you were switching to the laser in the middle of a job, you would want to touch off to the top of the material. But in this case, we can just move past and get to lasering. And we're off. We're starting with the engraving. As you can see here, the laser is rastering back and forth and making those lines. Eventually, when that's done, we'll switch over to the cutting tool path and you'll have yourself a really cool key tag. Thank you for sticking along with us in this tutorial, and we're really excited to see what you make with your laser.